All right, let's talk about one of the holy grails of AI research. Imagine an AI that doesn't just, follow a set of instructions. Imagine one that actually learns and gets smarter on its own, just by doing stuff. We're talking about creating agents that can improve through their own experiences, maybe even one day mastering things that are way too complex for any human. Okay, but here's the million-dollar question, right? In the real world, there's no answer key. It's not like a video game where you get points for every right move. Think about it. If an AI is, say, trying to book a flight on a website, how does it even know if it's doing a good job? There's no score popping up. So how in the world do you teach it to learn when you can't just tell it you got it right or you got it wrong? This is the huge problem that researchers are really struggling with.
So this brings us to what you could call the AI's learning wall. It turns out the main ways we've been trying to do this, well, they just aren't cutting it. They've run into some pretty big problems.
So you're basically facing this big training dilemma. On one hand, you've got reinforcement learning. This is where the AI learns by trial and error. Sounds good, right? But the problem is, without a clear score, it's just painfully slow and inefficient. It can take forever. On the other hand, you have what's called supervised fine-tuning. Here, we basically show the AI a bunch of perfect examples from human experts. But that's a problem too. That expert data is super narrow, it's expensive, and the AI gets totally lost the second it sees something new. So you're stuck between a rock and a hard place. One method is way too slow and the other is way too narrow. Yeah, and this quote really nails it. Using only that perfect expert data, it's exactly like just memorizing the answers for a test. Sure, you might ace that specific test, but have you actually learned anything? Nope. The moment you get a question you haven't seen before, you're completely stuck. It doesn't teach real understanding. So, how do we get over this wall? Well, researchers have come up with a really fascinating new idea, a sort of middle ground. They're calling it the early experience bridge, and it's a new way of thinking that tries to find a path right between those two flawed approaches.
Okay, so what in the world is early experience? It's actually a pretty clever twist. Get this. Instead of waiting for a reward signal, like a good job or bad job, the AI learns from its own actions. It just does something, and then it looks at what happened next. That outcome, the result of its own action, that's the lesson. The big idea here is that the AI learns from the natural consequences of what it does. No external score needed. You can really boil it down to this. It's all about learning from the journey, not just the destination. Every single step, every interaction, and yeah, even the mistakes, they all become valuable pieces of the puzzle for the AI to learn from. So how does the AI actually do this? Well, this whole early experience idea is built on two core strategies. It's all about learning from seeing and doing. And here they are: implicit world modeling and self-reflection. Now, I know they sound a little academic, but trust me, the concepts behind them are actually super intuitive. Let's start with the first one, implicit world modeling. This is basically the seeing part. The AI takes an action and it watches what happens. By doing this over and over, it starts to figure out the rules of the game, the cause and effect of its world. You can think of it like the AI is building a mental map of its environment, figuring out how everything connects and what's possible. Okay, now for the second strategy, self-reflection. And honestly, this is where it gets really cool. The agent doesn't just learn from perfect moves. It actually learns from its own screw-ups, its own mistakes. It can look back at a less than perfect action and go, that didn't work out so well. How can I do better next time? It's literally like us learning from our mistakes. And that is a massive leap forward from just copying perfect examples. All right, so the theory sounds fantastic, right? But the big question is, does it actually work? Well, let me tell you, the results are really promising. This really could be a game changer for the future of AI. And hey, the proof is in the pudding. Just look at this chart. The agents trained using this early experience method saw massive improvements in two really critical areas. First, effectiveness, which is just a fancy way of saying how well they get the job done. And second, and this one is arguably even more important, is generalization. That's their ability to handle new stuff they've never seen before. The numbers don't lie. This thing works. And this wasn't just a fluke either. The researchers really put this to the test. They tried it in 8 totally different environments with a bunch of different AI models. And guess what? The results were consistent every single time. It reliably made the agents better and more adaptable. This shows it's not just some niche trick, it's a solid, widely applicable technique. So what's the big picture here? Well,
Early experience probably isn't the final answer to everything, but what it is an absolutely crucial bridge. It's the practical step that gets us away from just simple, boring imitation and puts us on the path toward creating truly autonomous AIs that learn from the world around them. And that just leaves us with this one kind of mind bending thought to chew on. This research basically shows us that an AI can learn from its own childhood, right? From its own first fumbling, imperfect steps. So, if an AI can learn this much from just its early experiences, what on earth will it be capable of when it finally grows up?